So the key in order to determine which one of these possible transmissions of genetic information is to find which one of these would possibly allow for someone who is expressing this phenotype. So in other words, they have this disease, but then none of their children have this disease. So if we go to the autosomal, which is what most of us have been learning before this class, most of us are familiar with that type of Punnett square. In autosomal, even in autosomal recessive, if the female here, which it is labeled clearly for us, she's not even a carrier. If she's not a carrier, then that means that she can only pass on the dominant trait. And if she passes on the dominant trait here, and additionally, the other two mating pairs here also only have the dominant, and they're not even carriers, then there's no way for this individual down here at the bottom of the pedigree to be able to receive both recessive alleles. It just wouldn't be possible. So then, once you rule out autosomal recessive, then that can take you back to the X-linked recessive. And I don't know if any of you were able to watch the office hours, but a lot of the times X-linked recessive genes affect males a lot more than they affect females, because males, they only have the one X chromosome when we're talking about sex chromosomes, of course. And when that happens, such as in color blindness, they happen to express these phenotypes, these disease phenotypes, twice as often. So what we have here in the Punnett square for B, with the X and then the little a is the one that's coming from the male that's expressing that phenotype.